Hello there, it's Mr. Payton. How are you? Welcome to the help video for 4.05 Read and Write Algebraic Expressions Part 1. Let me just flip the camera around and we'll get started. All right, here we are. So lesson 4.05, Read and Write Algebraic Expressions Part 1. How do you say the expression we talked about in our warm-up yesterday when we did this little expression 10 plus 2x? Well, hearing me say it, I mean, that's sort of how I would just read it on my first go. There's a couple different ways you can describe the addition and the multiplication going on in this problem. I could say 10 plus the product of 2 and x. I could say the sum of, because that means add, right? The sum of 10 and the product of 2 and x. When I say the word product, you have to realize that that means multiplying. We can also refer to this variable x as a number or just some number. I could say 10 plus the product of 2 and some number. There's more than one way to describe any variable expression you see, and that's sort of the point of today's lesson. Let's see, the learning targets are being able to write algebraic expression after just hearing it said, like hearing it read out loud. That's what we mean by verbal phrase, or write the way you would describe it if you see it just in mathematical form. So one thing that's going to help you with today's topic is remembering all the words and closely related words that indicate to do certain operations, like with addition. You can say added, altogether, both, combined, in all, increase, more than, plus, sum, total. And keywords that typically mean subtraction, like decreased by, fewer than, less, less than, minus. Multiplication, some keywords for multiplication are times or triple, which specifically would mean multiply times 3, right? Triple or times or twice means multiply times 2. Per, which would indicate a rate. We'll get more into rates later on here in the school year. But then division, some keywords that indicate division, of course, divided, half, dividing by 2, out of something else, like 3 out of 5, 3 divided by 5. Percent, quarter, quotient. I think the most important keywords to remember here are the words that describe the answer to an addition problem, the sum, the answer to a subtraction problem, the difference, the answer to a multiplication problem, which is product, and the answer to a division problem, which is quotient. Those are really important keywords to have memorized. So an expression with numbers and operations, we call that just a numerical expression. We started looking at algebraic expressions, but we still need to be able to describe numerical expressions. If you see grouping symbols, you have to describe it in a way that indicates part of this expression is grouped. So here we have 6 and then parentheses and then 2 plus 3 and then close the parentheses. We have the numbers 6, 2, and 3. But what's going on here? It's 6 times like a quantity in parentheses. So there's a couple different ways you might read this out loud. You can say 6 times the sum of 2 plus 3. That indicates that the sum of 2 plus 3 is sort of a separate thing here. 6 times that whole thing. And you would write it like that. So why do we need to put 2 and 3 in? So if 2 plus 3 in this problem, if you were actually evaluating it and solving it, you would have to add the 2 and the 3 first, right? If we were solving this, we'd add the 2 and the 3 to get 5, and then do 6 times 5 to get 30. And if you read it incorrectly, like if you're just reading this aloud to somebody and having them copy down what the expression is, if you just say something like 6 times 2 plus 3, that person listening to you might write this down. And you're not going to get 30 if you solve it without those parentheses. Here you'd get 12 plus 3. You'd end up getting 15, right? That's 6 times 2 plus 3. Much different than 6 times And I like to use the word quantity. I like to read these like this. When I see parentheses, 6 times the quantity of 2 plus 3. And you see that's a little bit different than the way it's described here, but it means the same thing. It indicates that that 2 plus 3 is a separate thing that needs to be grouped. And if somebody reads that out loud for you to copy down, and if that 2 plus 3 is grouped like that, you would have to follow order of operations if you were evaluating 6 times 5 to make 30. Much different than 15, right? It'd be a completely different value. So 6 times 2 plus 3 is not the same as 6 times the quantity of 2 plus 3. Now let's talk about variable expressions, also known as algebraic expressions. Let's flip to the next page. Here we have x, we have 2y, we have 4. There's multiplication going on, there's addition going on. How would we read this? Well, this expression right here, x plus 2y plus 4. I don't really have a lot on this example. When I say 2y, you didn't hear me say times. I didn't say 2 times y, but it's implied. Okay, 2y means 2 and y sitting right next to each other. And typically with these algebraic expressions, we typically do not show the sign. We typically wouldn't say 2 times y when reading this out loud, but it's safe to assume here that 2y would look like that, and that means 2 times y. So I could also read this a little bit differently. I can say it's the sum of x and 2y and 4. Let's get into some different stuff. Here we have n plus 8. We can read this as a number increased by 8. A number increased by 8. If you just heard me say out loud, a number increased by 8, a number, that tells you what your variable is. We're just choosing to show n as our variable. If you could use x, I suppose, if you were just choosing your own variable. Increased by is a code word for plus, right? Increased by, plus, then 8's just 8. So I can read this as a number plus 8, a number increased by 8, 8 more than a number, the sum of a number and 8, a number plus 8. Did I already say that one? Maybe. Several different ways you can read it. How about when we're doing subtraction? Now there's a difference between less and less than. And in my opinion, that's the most confusing part of this lesson, is the difference between less and less than, because I typically don't ever read expressions just saying less. But in your K-12 lesson pages, they use this a lot. Like the expression m minus 5. You might hear this described as a number less 5. It's not 5. It's not a number less than 5. You'd have to flip it around for it to be less than. And to me, it's just less popular to read it like this, just saying less. But less is a synonym for minus. So like if you hear a number less 5, or I could even use another number instead of m or a variable, I could say 10 minus 5 is 10 less 5. But to me, that's just a little bit, I don't know, maybe it's more common in some parts of the country or other, I'm not sure. But when I say less, I typically say less than. And I would read this as 5. If you're saying less than instead of less, I would describe this as 5 less than a number. 5 less than a number. We could also say the difference between m and 5, a number decreased by 5, a number reduced by 5, a number minus 5. Just watch out with less and less than. Yeah, here we go. Be careful with less and less than. 5 less than a number. 5, right? You can read it as 5 less than a number, but if you're just using the word less, you would say a number less 5, which just to me sounds weird. So a number increased by 8. So look for your variable when you hear a number. It's like some mystery number. Here we're choosing n as the variable. So we see it there, we see it there, we see it there. We do not even see a variable in D. A number increased by would mean plus. 8 is 8. So here we have it. A number increased by 8, n plus 8. Here's a little matching exercise. A number increased by 12. Notice our variable is an x here instead of an n. It doesn't make any difference. Increased by still means plus. A number is my variable. Increased by 12 plus 12. 12 increased by a number, be the same thing, just the other way around. 12 plus x. A number 12 less a number. Here's where you got to be careful. It's less, not less than. So 12 minus our mystery number. A number less 12. There's our number less 12. How about this? 4 more than the quotient of a number and 3. We have to understand what more than means. We got to know what quotient means. All right, more than indicates adding, right? More than. A quotient is what you get after you divide something. So we know there's some division going on here, and we're adding. So let's break it down a little bit. The quotient of a number and 3 means an unknown number divided by 3. Something divided by 3. So that's just this part of it. 4 more than this whole thing, the quotient of a number and 3. So there we have the quotient of a number and 3. X divided by 3, or you could write it as a fraction, x over 3. 4 more than that, just tack 4 onto that. So here we have x over 3 plus 4. The quotient of a number and 3. 4 more than the quotient of a number and 3. Now here we show parentheses around the x divided by 3. It's a good idea to keep those parentheses, although they're not entirely necessary, because if you follow the order of operations, you will do the x divided by 3 first. I kind of like it written as a fraction. X over 3 plus 4. 4 more than the quotient of a number and 3. All right, let's look at another one. 5 less the product of 10 and a number. So look at like this whole part of the section as one thing. 5 less than, not less than, 5 less that whole thing. 5 less means 5 minus that whole thing. Product means multiply. So you're multiplying 10 and a number. So that could look just like this. 10x or 10 and some other variable. 5 less the product of 10 and a number could look like this if x is your variable. If I were to say 5 less than, very different than less than. If it's 5 less than the product of 10 and a number, it would look like this. Now in your lesson, they use d instead of x, which doesn't make a difference. How about this? 4 more than, that's something plus 4, right? 4 more than, quotient of a number and 3, that's going to be divide. See, we got to know that quotient means divide. A number is going to be my mystery number, and 3 is going to be 3. You could see here with option B, that shows a number divided by 3, 4 more than that, plus 4. All right, so this page is just a reminder that these expressions, we could use them to figure out things in the real world, like the amusement park example. But really, the focus of today's lesson is not to try to solve for x. It's just to be able to read them out loud, or if you hear them read out loud, could you copy it down on your paper? That's basically it. There's a reminder of the learning targets. So there's our warm-up. You could actually read this as 10 plus the product of 2 and a number. Or you could flip it around like this, 2x plus 10. You could say 10 more than the product of 2 and a number if you wanted to. Which is the correct way to translate this verbal expression into a variable expression? The quotient of, boom, there's my division, 14 and a number. So 14 divided by some number, less 27. That whole thing, less 27. 14 divided by x, minus 27. I don't see it written like that here, but recall that 14 over x is the same as 14 divided by x. Less 27. Which is the correct verbal expression for this expression? 8 times, here's how I would read this. 8 times the quantity of h plus 6. That is exactly how I would read it. 8 times the quantity of h plus 6. But I don't see that exactly here. There's more than one way to read these things. How about let's look at A. 8 and the sum of h and 6. Now that, if I were going to try to write A, I would write 8 and the sum, and would tell me just to maybe add it, the sum of h and 6. That doesn't tell me to multiply. All right, my expression up here is showing multiplication. It's 8 just sitting next to h plus 6. So it's 8 times h plus 6. All right, so A wouldn't work. How about B? The product of, that means multiply, the product of 8 and the sum of h plus 6. That indicates that the h plus 6, the sum of h plus 6 is a separate thing. It's 8 times that thing. I think that's what we're going for here. Let's just look at C and D though. The sum of 8 and h and 6, I think I would just do this. If I were trying to write down this expression, h plus 8, 8 plus h plus 6. There's no multiplying there. How about D? The product of 8 and h plus 6. This is the one that'll trick most students. All right, this sounds like it could be right. The product of 8, product means multiply again, 8 and h plus 6. But that tells me to do this. The product of 8 and h, I could just write it like this, 8h plus 6. That's different than 8 times the quantity of h plus 6. That's different. That's a different looking expression, but it's very close. That would be a tricky one. So the correct answer was B for this one. Which expression represents this word phrase? 25 decreased by, that's going to be subtract, the sum of 6 and a number. Look at that as one whole thing. If you're looking at this sentence sort of like studying the grammar of the sentence, that whole thing acts as a noun. That's like your noun phrase. That's the object of the preposition by. Decreased by that whole thing. 25 decreased by the sum of 6 and a number. That's what tells you need to use grouping symbols. Decreased by the sum of 6 and a number. 6 plus some number. 6 plus n. 25 minus 6 plus n. So if you were trying to read the rest of these out loud, you might say 25 increased by the sum of 6 and a number. C might be the difference between 20. Well, I don't know. Let's just move on here. I keep getting sidetracked. All right, let's move on to this one. Translate the verbal expression into a variable expression. 6 less than. Okay, so less than, not just less, but less than. That tells me whatever the rest is going to be, I'm going to do minus 6. Like, for example, if I just said 6 less than 10, 6 less than 10, you would write 10 minus 6. If I said 6 less than 100, 100 minus 6. So the minus 6 is going to come at the end here. 6 less than what? Here's our noun phrase, the quotient of 2 in a number. Quotient means divide. 2 is going to be 2. A number is going to be your variable. It looks like we're using D as the variable here. So the quotient of 2 in a number is going to be 2 divided by some number, D. We could also write it like this, 2 over D. And it looks like this is what we're going for right here. And you don't need the parentheses, but you could put parentheses around that. If you use 2 divided by D, it would definitely look better to keep the parentheses. I like to think that that's sort of a whole separate thing in this sentence. The quotient of 2 in a number, 6 less than that. All right. Which expression represents this word phrase? 15 divided by a number and then decrease by 2. 15 divided by a number and then decrease by 2. So we got to do this whole thing first. That tells me I need to use grouping symbols. 15 divided by a number and then decrease by 2, minus 2. This is what we're going for here. That's it for the examples. Good, I kept it at 20 minutes. That was my goal here. So please work carefully through the lesson pages. Please do not overlook all the on your own questions here. Nice set of problems for you to practice and check your work against the computer. Have a great weekend if you're watching this on Friday, October 29th, and I'll see you in class Monday.